Hello, Jonah. Say hi to Jonah. We're feeling sorry for Jonah in Florida. Not happening. They're supposed to be warmer today, right? Counting on it being warmer. All right. So we're talking about trig. By definition, these trig ratios the sine of an angle will be the ratio of two sides, namely the opposite and the hypotenuse. The cosine of an angle will be the ratio of two sides of a right triangle, namely the adjacent and the hypotenuse. And the tangent of an angle will be the relationship of two sides, namely the opposite divided by the adjacent. Yeah? Okay. So that's what we're recalling from the previous lesson. We have this little SOHCAHTOA piece, sine, cosine, and tangent, and we're going to delve into our calculators to see how this will help us. Okay. So sine of 35 degrees, take your calculator out. I'm going to walk you through the process to get to the right mode. There are two ways to measure angles. You can measure angles in degrees and in radians, just like you can measure distance in kilometers and miles, right? So we have to be in the right mode. So if we're going to talk about the degrees, we need to be in the degree mode. So take your calculators in your hand and hit the mode button. If you look down the mode button about 3 lines down or so, you have radians and degrees. Make sure you Game Boy key over to degrees and hit enter so that the degree part is black. Okay, you will need to do that anytime you reset your calculators. Okay, so before you start a test or a quiz, please make sure you're in the right mode. Okay, we're all in degree mode, everybody? Everybody there? Okay, so now all you have to do is type in sine of 35. So go get your sine button, type in 35, and give me 4 decimal places. So 0.57, I need 4 decimal places. 3.5. Is that the correct rounding?
No.
It's a 6? Okay, gotta have it right. Does everybody get 0.5736? All in favor, say aye. Let's go. Okay, good. That's how you do all of those. Okay, so what happens is that means when you have, what this means right here, everybody watch. Evan, up here. When you have 35 degrees, so let's say it'd be like that, right? 35 degrees about. When you have 35 degrees, what we have just discovered is that the ratio of the opposite side here divided by the hypotenuse side here will be 0.5736 every single time. No matter how you expand that, if you're at 35 degrees, the ratio of the opposite side to the hypotenuse will be about 0.57. So just a little bit more than 1/2, right? Does that kind of make sense? That's what we're talking about. When you're at 35 degrees, that's what we just learned. Okay, someone type in cosine of 35. Nah, let's do cosine of 58. Let's do this one. Cosine of 58. So in my triangle, 58 would be slightly larger. If this was 58, now I'm going to find out what the ratio is of the adjacent side, this one, to the hypotenuse. What do we get? 4 decimal places. Go.
5299.
5299. Is that rounding properly? Okay, 0.52999. So what we just decided was when I have a 58 degree angle, if I take the cosine of that, that will tell me that the ratio of the adjacent side to the hypotenuse is about 0.5299. That's what we're learning. Okay, turn the page. I mostly skip all this stuff. Calculators, type in your calculator. I'm going to skip all of that. Go to page 200. Just a minute, let me double check where I want to land. I'm going through this pretty quick. Okay. If you type in your calculator's tangent of 35, you get 0.7. And if you type in tangent of 58, you get 1.6. But what angle should we type in so we get the answer to be 1.2? So in other words, like this. Tangent of what angle? What goes in this box? So I get 1.2. Try a few different things and check it out. Take your time. We're just randomly guessing numbers and throwing them in there trying to get 1.2. Anybody try something that got close? What'd you get?
1.234.
But what was the angle that you tried? 51. So tangent of 51 is 1.2. What was the rest of it?
3/4.
Okay, so that's pretty close. Let's try something different. Can you get closer than that? What did you try? Try 50. Tangent of 50. What did you get when you tried tangent of 50?
1.191.
Ooh, 1.191. Okay, so we're close.
Actually, it's a 2 at the end.
There's a 2 here?
Sorry.
So that's close. That's pretty close, right? Because this 9 would kick this up to 1.2. So 50 might be better. Okay. You're like, do I always have to guess and check? Shouldn't there be a way to figure out what the angle is? And the answer is, of course, there is. Okay. So I'm going to take you on a little journey right now. Go back with me for a second. Remember when we did this? 3x equals 324. 3x equals 324. What do you do to solve this? Quickly. Divide. Why did you know to divide? Because dividing is the opposite of multiplication. What happened when we get this? How do you find C? Go ahead, Bailey. Square root. Why do you know to square root? Because square rooting is the opposite operation of squaring, correct? You with me? Okay. When you have tangent of something equaling 1.2, the only way to get rid of this tangent is to do the opposite operation of tangent. Now, here's what you can't do. Ready? You can no more do this. Just watch for a second. You cannot do this any more than you can do this. Okay, you cannot divide by a square root sign. A square root sign is a function. You can't divide by a function. Okay? Tangent of x, tangent is a function. You cannot divide by tangent. It's silly. It's like dividing by a square root sign. Okay? It has no meaning. Do you understand? Okay, so first of all, understand tangent is a function and you can't just divide by tangent. Don't ever do that. Okay, so then you're like, well then how do I get rid of the tangent if I just want to solve for x? What do I do? Well, we have a way, we have an operation that's the opposite of tangent, and it is written like this. Let me get rid of some of this here for a second. Okay. Tangent is written like this. That little tangent to the -1 in math notation means the opposite operation of tangent. But what you do to one side, you must do to the other. So we do that. And then tangent inverse tangent of tangent, that erases just like squaring a square root sign does. And you end up with x being equal to the inverse tangent of 1.2. And that button can be found on your calculator by hitting second function tangent of 1.2. So take your calculator and go second function tangent of 1.2, which should be pretty close to 50. What is it? If I was going for the nearest degrees, I would choose 50. Okay, so I do all of that. That information, that little bit of explanation about functions is not in your book, but I think it's useful to understand why we're doing second function tangent. We have to get rid of the tangent to just get x, and the only way to get rid of tangent is through the inverse operation of it, which is second function tangent. Just like we do square roots and squaring. Just like we do dividing and multiplication. You understand? Hopefully that makes me a good teacher to teach you that. Okay. All right, so let's go down here. First of all, something I have to tell you every single time is don't ever write sine, tangent, or cosine down without putting an angle following it. An angle is what follows the function. There's no such thing as tangent without talking about the tangent of an angle, okay? Any more than there's talking about square root, what's square root of what, right? You need to have a number in there. Same thing. So every time we write down sine or tangent or cosine, we always follow it by an angle. You must put down the angle. I will never allow you to write this. Sine equals 0.3584. I will mark it wrong every single time. That is bogus. There must be the sign of something here, okay? You have to have an angle following. Okay, so what do? Now we are not able to type in sine of the angle. We don't have the angle. We're looking for the angle. So you need to get rid of the sine thing. So what we do is we do the inverse operation of sine on both sides of the equation. So we balance the equation. That's gone, and we get a to b. You tell me, second function sine of 0.3584. 29 to the nearest whole degree. Is she right? Oh, 21. Okay. Okay. All of these would be the same. So cosine of b is equal to 0.5389. If you want to get the b alone, you got to drop the cosine. The only way to do that is to do cosine inverse of both sides, keeping our equation balanced. Second function cosine of 0.5389 is 57 to the nearest whole degree. Someone confirm that number. Yes, 57 degrees. Okay, so that means if I had a triangle, I'm just going to tell you what that means. If I had a triangle and I measured 57 degrees, that was 57, that would mean the ratio of the adjacent side to the hypotenuse would be 0.5389. That's the ratio of two sides. Okay, so we can do all of those for all of those examples. All right, let me see what else I'm going to get to. I skip a lot of stuff in here. I don't think I do that. Let's skip this whole page. Okay, I go to page 213. And I am going to show you how to do class example number 7. This is going to be found. You'll be asked this exact kind of question on your homework. I believe it's number 12. Yes. So, would you please write beside this question? Right beside this question, number 12. So when you get to number 12, I don't want you to put your hand up. I want you to look back in your homework and see if you can figure out how to do this first. Then if you can't figure it out, put your hand up. Okay, but I'm going to explain it to you right now. It says, draw a triangle, LMN, in which angle L is 90 degrees. We can do that. So go get your triangle up here, draw a triangle. We'll call that 90, and we're going to call it, it's L. Okay, the other ones have to be M and N. It doesn't really matter, but just for my sake, put the M at the top and the N at the bottom. I don't care, but just so yours looks like mine, do it like me. We're going to call N angle X. We're going to call angle N X. So put a little X in here. Okay. And then it says, write an expression for the measure of angle M in terms of X. Here's what we're talking about. Let's talk about the angles in every triangle. What are they? How much angles add up to in every triangle? 180. The angles add up to 180, agreed? So, but that is a 90 already in the corner. So how many degrees do I have left to fill up my other two angles? 90 degrees left, right? You have 90 already, so you have 90 more to go. So isn't it true that angle M would be equal to, let's see, hold on. Let me just do a quick example over here. If you knew this was 90 and this was 20, what would this be? Quickly. 70. How'd you get that? 90 minus 20, right? If you knew this was 30, oh, you're already saying it. 30, you know this would be 60. Why? Because 90 minus 30 is the other angle up here. Agreed? So if I tell you that this angle is x, what will this angle be? 90, take away whatever that is down there. Do you agree? Do you know what just happened, Owen?
Yeah.
I think my sweater just gets in the way sometimes. Okay, so are you okay that m is 90 minus x? Whatever that little x is, I would go 90 minus to find out what that measurement is, what's at the top. You okay with that? A little bit? Just like I said, well, if this is 30, this has to be 60, 90 minus 30. If this was 15, you would say, well, that's 75, right? You with me? Okay, so first of all, angle M can be written as 90 minus x. Now then it says, explain why using ratios that the sine of x is equal to the cosine of 90 minus x. Okay, so right here, I want you to say, this is sine of n. How come that is going to be equal to the cosine of angle M? Is that true? Now let's just think about that. Is the sine of one angle equal to the cosine of the other angle? Of course, not the 90. That's what that says. It says that the sine of one angle is equal to the cosine of the other angle. Let's go see if it's true. Let's call this pretty soon, like in a minute or two, in 5 minutes, you will label these sides. This will be called little n. This side will be called little l. And this side will be called little m, smaller lowercase letters. Do you know how I did that? Opposite of the angle is the side, and we call the side the same letter of the opposite angle, just in lowercase, okay? That's just so we can keep it clear. So label your sides. With me, Evan? Okay, now, sine of n, what is sine equal to? Think about SOHCAHTOA. SOHCAHTOA. Just can't help but say it like that. I think it sounds great. Oh, Dr. Wu would be so proud of you. Okay, so SOHCAHTOA is the acronym that we use. So what are the sides that the sine ratio uses? Opposite and hypotenuse. So from letter X, or from angle N, the opposite side would be what? N over hypotenuse, which would be L. Agreed? Okay, now let's switch angles and let's talk about angle M up here at the top. This one up here. Let's talk cosine. Cosine, according to my SOHCAHTOA, is the two sides that will be in ratio to each other are the adjacent side and the hypotenuse. What side is adjacent to angle M? N is adjacent. It's next to it, right? So this will be N over the hypotenuse is still L. Check it out. It is true. The sine of one little angle is equal to the cosine of the other little angle. Cool, huh? So if this was 20 and this was 70, you would say sine of 20 equals cosine of 70. You following me? It's a really cool fun fact. So down here, the sine of 20 is equal to the cosine of 70. I just did that one. How about the sine of 8? What would it be equal to? Cosine of 82? Did you just catch what happened? These two things add up together to get 90. It's a really cool fun fact. Those things add up together to get 90. Now, that isn't I have to understand this completely or I'm going to fail this test. That is not this moment. Just a kind of a fun fact, okay? So that is for question 12. I'm gonna move on. I can explain this to you again if you can't get question 12 in your homework, but I also want you to check this out before you ask me for help. Try to see if you can get it. Okay, turn the page. Oh, we have an assignment. Okay, you have till the bell goes. I think the assignment question is super simple. 12 is the only one that's hard. A lot of it is calculator work. Make sure your calculator's in degree mode. Go at her.